So in this video we want to talk about drawing a phase portrait. So I'm in my Math 195 MATLAB folder, and I'm going to create a new script. This script is going to mimic sample code provided by Sayama. Now he provides this in Python, and we're going to adapt this to MATLAB. So on the first line I have put the title of my script, and so I'm just going to copy that. And I'm going to save. Remember, always save your M files in your Math 195 MATLAB folder and make sure that is your current working directory. Okay, second line I'll leave blank, and then I'm going to include some comments. So this script makes a phase portrait for x sub n equals 0.5 times x sub n minus 1 plus y sub n minus 1, and y sub n equals negative 0.5 times x sub n minus 1 plus y sub n minus 1. So you might want to take a moment to think about this. This is a 2D or two variable system. It is a linear system. It is autonomous, and it is first order. Next, we want to look at some initial conditions. Now, up until this point in our course, we've always picked a specific value for our initial condition, and we've run the simulation. In this script, we want to actually look at what happens for a range of different initial conditions. Like if we start x naught at -2 and y naught at -2, what happens? What happens if we start these initial values at 1 or 0.5? Right? So we want x naught and y naught, our initial conditions, to range over -2 to 2 in increments of 0.5. So we're going to run this for lots of different initial conditions. We'll do this for 30 time steps, and again, this is a model that's been modified by Sayama. Okay, so let's start setting up what we need. T equals 30. This is our number of time steps. What else do we need? Well, we'll need an array to hold the values of x and y. So let's say x equals 0s, 1, t. Let's say y equals 0s, 1, t. And I'm suppressing the output at the end of those lines. Now, I need to pick some initial conditions. And to do this, I am going to let a range from -2 to 0.5 up to 2. Similarly, I'm going to let b go from -2 in increments of 0.5 up to 2. Now, if you're wondering what the heck does that for loop do, let's go down here and take a look. Suppose I have a for loop that says a -2 to 0.5 up to 2. Okay, let's just display a and end the for loop. Let's see what this does. Okay, what that did, it was a for loop. It started our index variable at a, and it's going to march up until it gets to 2, and it's hopping up in increments of 0.5. So anytime you encounter code that you're a little bit unsure about, just come out to the command window and play with it a little bit so you see what the command is doing. Okay, so let's go back to our script. We've got for a equals -2 up to 2, and we're moving in increments of 0.5. Same thing for b. So we're going to initialize x and y. So we start indexing at 1. The first position in our array is going to have the value a. And for y, we'll set that to be b. So the first time we come through this double for loop, a is -2, b is -2, and so that means the initial value for x will be -2, and the initial value for y will be -2. And we'll run around in this inner little for loop for b, and that'll keep changing the initial conditions for our y value. And then we'll hop out to the outer layer and repeat that as we change the values for x. Okay. Next thing we want to do is we want to run the simulation. So at this stage, we're going to have another for loop, and let's index this one with n for n equals 2 up through our number of time steps. Here's where we need to run the model. So I'll just go up and grab x sub n, and I'll go up and grab the code for y sub n. We'll end our for loop for n, and I'm just going to make a note. We've got several for loops here, so this is, which one are we ending? We're ending the one that has an index over n. At this point we want to plot x versus y because this is a phase portrait, and we're going to hold on to that plot. We'll end our for loop for b, and then we'll end our for loop for a. Let's save and run. I'm just going to go up here, copy paste the name so I don't have to type that. And our command window got a little bit messy, so let's clean that up. And I'm going to clear all variables because I have some variable a over here, and I certainly don't want that to be messing up my code. Okay, so let's run, and we get a beautiful phase portrait. Now you notice there, it looks like there's a fixed point at 0, 0, and you could verify that analytically.